Good morning, everyone. Thank you for joining this HeatSource webinar on ground source heat pumps, the green heat beneath our feet. I can see that there's still some attendees joining, so we'll just give them a few minutes to get settled, and then we'll get started. First of all, for those of you that don't know, my name is Emma Church. I'm an impact manager at Built Environment Smarter Transformation, and we deliver the HeatSource project on behalf of Scotland's economic development agencies, that being Scottish Enterprise, Highlands and Islands Enterprise, and South of Scotland Enterprise. The webinar today, we've got a range of speakers for you from the green ground source heat pump sector. And just a couple of housekeeping notes. This session will be recorded and will be able to view on the YouTube channel early next week. And sorry, Mark, can you just pop your camera back off for just 1 second? Thank you. There is a Q&A session scheduled for the end of the webinar today. If you'd like to ask a question or leave a comment, do click on the chat and questions control panel box, type in your questions and press send. There will be a couple of poll questions throughout the webinar, and these will appear automatically on your screen, and you'll be given about 30 seconds to answer. We would really appreciate if you could contribute to them. It just gives us some insights and some talking points for our speakers. And also, directly following the webinar, you will be given a feedback form. It's extremely valuable to us, and we do take on many suggestions, so please do fill that out. So I think that's us. We'll get started now. So today we've got 4 great speakers, all experts from the ground source heat pump sector in Scotland. First up, we've got Ken Gordon, CEO of the Ground Source Heat Pump Association, the UK membership organisation for the ground source heat pump industry. Then we have Mark Potter, Regional Sales Manager for Scotland for Kensa Contracting, part of the Kensa Group, who manufacture, specify and install ground source heat pump systems across the UK. Joan Pisanek is up next, Business Development Manager for Cenergist, who support their clients to decarbonise the built environment and the buildings within their client portfolios. And then finally, we'll hear from Graeme Ross, Managing Director from Greystone Energy Scotland, with a wealth of installation experience across commercial and domestic installations of ground source heat pumps in Scotland. So yeah, lots of expertise and lots of great contributions, apologies. So just a quick overview for those of you that are new to HeatSource. This is a project, like I say, we deliver on behalf of Scottish Enterprise, High and South of Scotland Enterprise as well. Ultimately, with the heat and building strategy that clearly identifies heat pumps and heat networks as the low and no regrets technologies to help us achieve our net zero goals in decarbonising our heat system in Scotland. There is a great opportunity for Scottish businesses to benefit from that transition, and HeatSource is here to understand what some business challenges might be in terms of taking advantage of those opportunities. We conduct one-to-ones with businesses, so if you would like to speak with us, do please reach out. There'll be plenty of links to our resources, websites, newsletters, etc. in the chat. We run events like this, so raising awareness of different technologies, and also providing in-person events over the course of the next 18 months. Will give you an opportunity to network with others in the sector. So here are some links. We will share the slides from all of our presenters following the webinar, and you'll be able to click those links. But if you head to the chat boxes just now, there will be plenty of links for you to engage with following the webinar. So first up, we have Ken Gordon, as I mentioned, CEO of the Ground Source Heat Pump Association. He's going to give us a little bit of an overview of the state of the sector. But just before we start, Ken, we've got a quick poll question that was going to go out to our audience. The question being, ground source heat pumps are more costly and more difficult to install than air source heat pumps. Do you agree, disagree, or unsure? It's just a little bit of a kind of prompting question to try and understand maybe some of the preconceptions that our audience might have around ground source heat pumps. So please, if you're watching, do cast your vote. Do please contribute to the poll, and we'll see some results coming through shortly. Again, this may influence some of the Q&A and discussion that we'll have later on. Okay, there we go. So the perception mostly among our, actually by quite some margin in our audience, is that they are more costly and more difficult to install than air source heat pumps. With that intelligence and with that kind of scene setting in terms of like understanding our audience a little bit, Ken, I'll hand over to you. Great, you can share your slides now.
Yeah, well, thank you. That's a great introduction. Straight into the lion's den, eh? Let me just share my screen. Sorry, guys, I've lost the screen sharing bits. Can you help me on this one, please?
And I'll sort this now.
Yeah. That's it. You sent it through. That's it. Perfect. I can get it now. Thank you. I've clicked it, but nothing's happened. This worked perfectly 10 minutes ago.
Yeah, Ken, we can see your screen okay. Do you want to just maximize it? Screen?
Right. Yeah. Okay. Right. That's good. That's good. That's working slightly differently. Okay. So
perfect.
Yeah, I'm Ken Gordon from the Ground Source Heat Pump Association. Oh, sorry. Let's flip back in. And we're a group of 170 odd companies across the United Kingdom and Ireland, and our job is to really to explain how ground source works properly. We do a lot of lobbying work with governments. So, for example, yesterday the Scottish Government published their long-awaited Delivering Net Zero for Scotland's Buildings, Heat and Buildings Bill, and I'm not going to go into it now, but we would supply our members with these overviews of what we feel is required with this consultation. That's for energy. This is for heating. I'm not going to go into that now because really what I want to do is explain what a ground source heat pump is. So mostly we hear that it's a refrigerator in reverse. So here's a refrigerator in reverse, but actually it's not. A ground source heat pump is actually, it's just the same as a domestic fridge. It pumps heat. So in the fridge, the heat is extracted from the air inside the fridge and pumped out the back of the fridge through that mesh that you can see and feel that's warm at the back of the fridge. So when water is cooled in a heat pump system, unlike a regular fridge where the extracted heat is expelled into the room, the heat is transferred to the warm water and used for central heating in the hot water taps. So in a heat pump, water is first chilled down to 5 degrees and then is circulated through a pipe, as you can see there, runs down through a narrow borehole drilled in the ground and then back up again into the fridge. But the temperature of the borehole in UK is around about 10 degrees. So what happens is that cold water going down gets warmed up. And when it gets to the heat pump goes, oh, you're too warm, I'll have to cool you down again. And of course, what then happens is it has to pump that heat somewhere. And instead of out the mesh at the back of your fridge, it goes into your floor heating or into your hot water tap. So I apologize for going through that really, but I just hear so many things about, bluff and black magic about heat pumps. They are pretty simple things because we all have one in our house. So ground source heat pumps, two good ways to save energy. We know about making insulated buildings that are airtight, preferably with some sort of ventilation. But also it's important to reduce the emitter temperatures. And by emitter, I mean radiators or floor heating. So here's just another analogy here to try and demystify this whole process. But if you can look at this as a water pump, here you got a water pump pumping water from a reservoir up a hill. Now the light blue light blue tank there is halfway up the hill, and the dark blue tank's all the way up the hill. And it's just a very simple law of physics that the energy in the to take it halfway up the hill is exactly half of the energy required to take it to the top of the hill. And you know, everybody kind of gets that. So I want you to try and imagine now that this is not a hill in meters, but a hill in temperature. So there we go. On the right, we've got the hill in temperature. So this time we've got a heat pump that's pumping it halfway up the hill, which is a low rise in temperature. And the other one in the dark red is all the way up the hill. And the difference there is that if you're pumping to a lower temperature, it's going to take half the energy of the temperature at the top. And this is something that just very few people get, and why it's so important to have low temperature radiators, or even better, low temperature floor heating. And I don't mean by putting coils into the floor, into the concrete. I mean, why would you do that? These coils lie on top of the floor and underneath your floor coverings. I mean, for example, if you had a radiator, it was in the way of the sofa, you wouldn't bury it in the concrete in the wall. Why would you do that with the floor? So what we want to really do today is to move on from the sort of basics of heat pumps and to talk about shared ground loops. This is really probably the main way forward that we're going to scale up in the United Kingdom. With shared ground loops, what happens is that we drill maybe 2 or 3 boreholes for 5 or 6 houses. And these are known as 6th generation or low entry ground loops, ambient heat, but we just call them shared ground loops because that's what they are. There are quite a few current schemes on the go. Kensa Utilities we're going to hear from shortly. Cenergist we're going to hear from shortly, and there is another one in UK called Rendesco who also work in Scotland, and you'll find them on the website. But what are the blockers to shared ground loops? Well, guarantees, you know, who's going to look after it in the future, who's got statutory access, and lack of publicity. All of this will be solved with the government, Scottish and UK government, looking at shared ground loops. Heat networks. So what's the benefit of the shared ground loop over a normal heat network? Well, it's decentralized and it's low temperature. So basically, the water and antifreeze in the ground loop and the inhibitor runs at a very low temperature, 5 or 6 degrees. So as it goes through the ground, it doesn't lose heat, it's actually gaining heat as it goes along, and it doesn't need any insulation. So it's just a perfect solution. So here's the Heat Network Scotland Act that I'm talking about, which will support the growth of this type of system. Plus, it will have a lot of consumer protections as well, because you know, if you're on a heat network and you don't like it, where do you go if somebody puts the price up? With shared ground loops, much easier because you're not so entrenched in the ground loop. So here's some ground loop systems. We'll hear a bit more from Kensa shortly, and that's one way of doing it. So you have like 4 houses there and 5 ground loops. Sorry, I'll start again. 4 houses and 5 boreholes. Or we've got over here the thermal earth one where they're all shared through together. Just different ways of doing it. And here we have an idea from Rendesco, and you know, the preferred way of sharing ground loops is on the right there, smaller individual heat pumps and shared ground loop. But sometimes there are areas of heat that you can recover, say from a sewage treatment works or from a supermarket or from an incinerator, and it makes sense then to, you know, to utilize that as part of the system. I'm not going to go through all of these things, but we heard at the beginning there why ground source heat pumps are more expensive than air source heat pumps, but look at all those benefits that you have, and these will be shared afterwards so you can go through them in some detail. And if we're in inner cities, I'm sure we don't want to end up with all our homes with a fan blowing noisy air through it. But you know, how do you get in to do a ground source? Well, there's a company called Celsius Energy who gained all their knowledge not too far from where I'm here in Aberdeen, where they drill directionally, and they can go from a very small area and drill the whole site, including underneath the building, to get the heat required, because it is important that the heat is drawn from the ground at the same rate as it flows in, which is just basically gained from the sun over the months and years. Important, of course, to make sure that these ground loops are all work well. And this is a little bit too techie here for today, but it's just the fact that we do really like to look after our ground loops and make sure that they're tested and finished correctly. So that's kind of us, the Ground Source Heat Pump Association. We've got, as I say, 170 odd members, including some interesting people here. We've got Kensa, Greystone and Cenergist, who are going to be speaking, all members of the Ground Source Heat Pump Association, because without them and all the others, we couldn't do this work and support everybody. So that's kind of me finished now. So I'll pass over to Mark, who is the Regional Sales Manager for Kensa in Scotland.
Good afternoon, everybody. Morning, sorry. Emma, I've got no screen at all.
Hiya, Mark. We can see your home screen there. If you wanted to press your
right, okay. Yeah, but you got that now?
Yeah, just make that full screen and that's great.
Okay. Right, so good morning, everybody. Thanks very much for coming along. A little bit about...
Sorry, Mark, do you want to swap over to presenter mode and your display settings?
Yeah.
Perfect.
There we go. That you? Cool. So, yeah, thanks for joining us today. Just a little bit about Kensa and a little bit about what Kensa Group do. Kensa Group comprise three divisions: the heat pumps, which is the manufacturing of the ground source heat pumps themselves, which we do in the UK at a manufacturing plant in Truro, which has been recently upgraded to supply upwards of 30,000 ground source heat pumps per annum from a previous maximum of 3,000. So it's quite a sizable investment in the infrastructure for producing heat pumps in the UK. Kensa Contracting, which is part of the organisation that's responsible for project management, for design and installation of the shared ground loops that Ken mentioned previously, and Kensa Utilities, which is a funding arm of Kensa, which may go some way to addressing some of the concerns about the cost for ground source heat pumps. I'll go into that in a wee minute. We recently had the UK's largest investment in ground source heat pumps from Legal & General and Octopus Energy, who obviously both have long-term energy decarbonisation ambitions. At the moment, Kensa supply more than 50% of the ground source heat pumps in the UK. They've been doing so for 25 years, and they have the smallest, quietest and most efficient heat pump range on the market, and obviously made in the UK. It saves us a few issues with supply chain risk, etc., and lots of awards. This is our shoebox that we call it shoebox. The new one's called NX, but as you can see, it fits inside a storage cupboard, an airing cupboard, and very often you see them with the box with a cylinder above. So it's nice and simple. It's nothing that people are not familiar with. We're also the only ground source utility registered with Heat Trust, which provides consumer protection. Yeah, one of Ken's slides. I always have a wee bit of a shake my head moment with this one. Shared ground loops generally tend to have fewer boreholes and more heat pumps, is the idea. So, you know, one borehole for two houses, for example, which makes it a heat network. But as you can see, oh, what's happened? Sorry, folks. Can you still see my screen? Ah, there we go. Yeah, as you can see, we move quite close. We can work quite closely to the building, and the size of the borehole is about 6 inches across. So it's not a big operation to get boreholes into the ground in terms of disruption to properties. And as you can see on that slide, there's a flow and return pipe coming out of the borehole, which would then get put into the property for connection to the shoebox heat pump. As you can see, zero visual impact after installation. In this occasion here, the trenching, the manifolds here in the front and the boreholes are underneath the slab here and trenched into the properties. Obviously, with a building like this, it'd be very difficult to put air source that. So this is all being serviced, and there's about 4 blocks flats similar to this on that site. That's the back of this building here. We've done projects in Scotland for Lar housing at Fountain Bridge. This is an interesting one because the site here to the right of the drawing on the picture on the left, you can see the canal. That is a converted church, and these are new builds. So it's a combination of both old and new properties right next to the canal, and in an area which was pretty challenging to get drill rigs in and get boreholes done. However, all the things that they said GroundSource couldn't do, we did. This is a new development at Dunbar, just outside Edinburgh, where a private developer, and it's the first of its kind in the UK, a private developer has designed and built the properties with GroundSource heat pumps. And that will be part of a management fee for this site that people will pay for, and I'll go into that in a little bit later. And this one here, Ballater, obviously one of the coldest places in Scotland and in the UK. These are old stone, it's an old stone converted school building, and we've got cylinders and heat pumps in there. So yeah, just to show that we've got a pretty flexible option for it. As you can see, the boreholes are installed in granite bedrock, so and the borehole depths are down to 150 metres. Borehole depths can go down to 200 odd metres, and we've got one site at the moment where we're drilling down to 300 metres, and it's challenging, but we've got pretty good experience in doing that. In addition, we have GroundSource heat pumps can also facilitate cooling, and in passive cooling, we can draw the heat from the room and put the heat that we take from the room in the summer back down the shared ground array and put it back in the ground, which is then stored. Basically, the ground is a massive storage facility for the heat, and then obviously by doing so, we can then recycle that heat back into the properties in winter, which makes it more efficient. We have heat pumps for any scale. These are our non-domestic heat pumps, which we can cascade up. You know, we've got projects with a megawatt of heating, and that would service traditionally facilities like schools, leisure centres, warehouses and buildings and such like. And Kensa go through all of the initial feasibility, look at investment opportunities, funding applications, planning support, design and installation if where required. So it's a turnkey solution for big facilities like schools and whatnot. The beauty of shared ground loops and this system is that it can be used within urban areas with a minimum of disruption. You can see here we've got shoe boxes in all the apartments. We've got larger heat pumps, domestic heat pumps in the larger properties, and we've got the non-domestic large-scale heat pumps in things like shopping centres and whatnot. We can also draw the heat, the excess heat from those buildings. So where there's excess heat generated behind the solar PV panels, where there's excess heat from the refrigeration systems within supermarkets, we can take that excess heat, return it back to the ground in exactly the same way, and then use it again later, making the system more efficient. And you can see there, rejected heat from supermarkets can be returned back to the ground array. The ground array is, the ground source heat pumps are the lowest running cost, the least noise, least maintenance. As you can imagine, we've got a shoebox in a house rather than a fan-based box out in the garden. There's no visual impact, and we've obviously got the opportunity to run passive cooling. The survey at the start, more costly, yet the ground infrastructure, in the same way that the infrastructure for the gas network 70 years ago was expensive to install, the ground infrastructure is the more expensive part. The heat pumps are a similar sort of price, but you've got a number of factors which also come into play. In order to deliver heat on the coldest days, a ground source heat pump is more efficient. The grid is not under the same stress as it would be with air source trying to pull heat from -5, for example. The heat source is outside, whereas ours is in the ground and then comes into the building. That gas network that we talked about looks like this. A ground source heat network is exactly the same. Now, you'll see here Kensa Utilities. Kensa Utilities was set up in order to fund this bit, the infrastructure in the street, so that we took away some of the pain of the cost of installing a whole system. There's some numbers here, we'll share the slides later without getting into too much detail on them. When you include all of the costs for air source against ground source and the savings that can be made, it actually costs less per annum to run a ground source heat pump system than it does an air source heat pump system. So although the upfront capex seems more expensive, at the time there's funding, and in Scotland we've got the Scottish Heat Network Fund as well, which is a huge sum of money that people should be looking to tap into, and we can obviously help with that. The Kensa Utilities funding would require the tenant or the housing association or the private tenant, whatever, to pay a standing charge in exactly the same way as they pay a standing charge right now. It's the same as it's monthly, the same as with your gas. It's for 40 years, but then you can continue that as long as you've got the ground source heat pump in your property. We look after the operation and maintenance of the infrastructure. If you move house, the standing charge stays with the property. It's protected by Heat Trust, and we are flexible as to who gets billed. It's private development. They all get the private development I mentioned earlier. They have a management factor who take factoring fees, and we bill them. But social housing landlords can do it as well. And obviously, we're here to decarbonise our heating network, and you can see that ground source has the lowest, has the best ground decarbonising features. So you can see here, the state of some of the numbers. We've got 5 million homes in Scotland by 2045 to decarbonise. That's approximately 4,371 per week in Scotland, and I think we did about 1,000 last year. So we need a street-by-street approach to address this, and I know that Joan will speak about this next as well, I'm sure. But we're looking for this middle ground where we have individual heat pumps on one end. We've got big city-scale district heating networks here, and then we've got millions of properties in this area here where a shared ground loop would be suitable, where we go up the middle of the street and supply into these tenement blocks, for example. And if anybody's got any questions, that's myself and Donna, who looks after our non-domestic. That's me. Hand you over now to Joan.
Thanks, Mark. Just going to get my presentation up here, hopefully.
That's perfect, Joan.
Can you guys see it?
Yes, that's perfect.
I can't see anything, sorry. Apologies, just bear with me. Sorry guys, I can't see anything at all.
I'll make myself presenter again, Joan, and then put it back on and see if that helps. Maybe
Okay.
the screen that you choose to share could be something to do with it. Or if you're on two screens, we'll give it another go, okay?
Okay. Okay, can you see that okay now?
We can see that, yeah. Is that good?
Perfect, thank you. Thank you for that. So my name's Joan Pisanek. I'm a business development manager with Cenergist. I started off working in energy storage and then moved into district heating across the city. And I've now joined Cenergist, where we do more communal heating and occupied social housing blocks. And that's really what I enjoy the most. So I'm hoping to tell you a little bit about the residents and what the residents actually see when we're doing these projects. So Cenergist was founded in 2012 and originally to do consultancy with public and private sector clients to help them meet their net zero and sustainability goals. We've now moved into actually completing the projects, so we provide a full turnkey service on the projects. We'll do an initial high-level appraisal of the project, and then we'll do a detailed feasibility study right through to the delivery of the retrofitted heating projects. We supply the consultancy, the design, the M&E engineering, funding solutions, which is really important, all the construction, tenant liaison, and the site manager. We employ 170 people at the moment. We're throughout the UK, including Edinburgh, and we also have our offices in Spain, the Netherlands, and India. And we also have our own in-house brands, so we can provide the drilling, the renewables, and underfloor heating systems to both domestic and commercial users. And we have technical expertise across a full range of energy efficiency, low carbon heating systems, renewables, and water efficiency technology. The water efficiency technology is never that important in Scotland because we don't pay for our water as it's metered. But because we're having to pay for the water to be heated, the less water we use, the less we have to spend. So that's actually becoming quite important now. But we're one of the largest installers of ground source heat pumps and communal heating systems in the UK. And we specialise in upgrades to existing district heating networks. So we'll optimise those, make them much more efficient, or first time installs of communal heating into existing occupied blocks. We're both technology and manufacturer agnostics. We don't develop our own heat pumps or anything. We work with lots of different manufacturers, and we'll basically look at the building, decide what's the best option for that building, give all that information to the customer so that they can make an informed decision. So this is an example of a project that we did in Leeds. We did this for Leeds City Council. We've worked with them a lot. We converted 22 blocks from electric storage heaters onto a communal ground source heat pump system. You'll see there we did 6 blocks with an air source heat pump system on natural refrigerant. And that was the first of its kind in the UK. The reason that we did air source heat pump in those blocks is because we couldn't do the ground source. That would be because there's not enough land around, or there's just some other reason why we couldn't. So that would always be our second choice, would be the air source communal heat pump after the ground source. The services we provided for that were the appraisal of the different systems. We did the design of the best technology for decarbonising, and we would consider the capex, the carbon saving, the residence bill, and how we could fund that. So in this case, we would have used probably the heat network, the green heat network funding that's available in England. In Scotland, we'd consult with the heat network unit, which is very, very good, and we'd look at the heat network fund or possibly the social housing net zero fund for some of the domestic works. We'd certainly try and blend the funding to get the best, basically to get the maximum funding we can get for these projects. So this was fully scrutinised by ARUP, and we ended up with a lot of the recommendations we made actually being incorporated into the CIBSE heat network guidelines. And you can see there that we had a 65% reduction in CO2 emissions and a 52% reduction in the resident bills. So that actually makes a massive difference to the residents in those buildings. I'm always being asked what's the difference between a district heating network and a communal heating network. And we know at the moment we've got 1,080 heat networks, and this is from the heat network delivery plan that Scotland did, which supply around 30,000 homes and 3,000 commercial buildings. Now, if you look at that, if you do the maths on that, that's about 40 residencies per heat network. So those are typically quite small. They'll typically be assisted living complexes where you've got a central plant room providing heating and hot water into each of the little apartments. So that the figures that we've got suggest we've got about 1.18 terawatts of heat, but in 3 years we need to reach 2.6, so we need to basically double that capacity. And then in another 3 years we have to double that again. So it's quite ambitious, the plans that we've got for these heat networks. And district heating so far in Scotland, we still don't have a lot of the very big citywide systems, and that's changing. If you look at just the central belt, we now have obviously the world-class Queen's Quays over in Glasgow. We've got lots of plans for Glasgow. We've got the Midlothian plant starting soon. The St James Quarter has a district heating network, and we're looking at the Granton. So those will take up a lot of that that number, but we still have a lot of systems which are not near each other, smaller plots. So the big difference between district heating and communal heating tends to be, number one, the scale. District heating would tend to be across a very wide area, and it would look to take in a lot of different types of building, typically some residential, some leisure complexes, schools, hospitals, sort of large heat loads. And that's why they need the anchor loads. They need sort of large buildings that are going to take a lot of that heat. If they're producing 10 megawatts of heat, 5 megawatts of cooling, they need big off-takers for that heat. The ground source communal systems will tend to be one block or maybe a couple of blocks, but it's a very small area that's taken into consideration. The ownership model is probably where it's more different. So typically with any kind of communal or district heating, you'll have design, build, own and operate. Now with the district heating, you'll tend to have an energy services company that will quite often partner with a council, and they'll have a contract that runs for 25 to 40 years. It's typically 40 years. And they will design and build, they'll own and operate that district heat network. So what that means is they will go out, they will find customers for that network, they will manage that energy plan, and they will bill the consumers. So the consumers are then in that system for the 40 years or however long that they're attached to that district heating network. With the ground source communal system, we will design and build. So Cenergist don't do the operation. We can help people with metering and billing, but we don't do it ourselves. We will build that bore field. That will then be passed over to the council or whoever is commissioning that build. There are options for utility companies to take over that bore field, and they will then provide a performance guarantee. But in return, they will make a small charge on each of the residents, but they don't they don't restrict you to only using them as a supplier. They'll give you a performance guarantee, and they'll also give you an upfront payment. So for consumers, the big difference is with the district heating network, you are tied to that energy supplier, so you must buy your energy from that supplier. I know there's been a lot of scare stories about them being expensive, but it's not actually true in real life. They're generally very competitive. They can quite often supply energy at a much lower rate. The ground source heat pump, you are free to choose whichever energy supplier you want, because you'll have your heat pump within your property. So I wanted to try and give you some pictures of what actually happens when we're doing these projects at site. So we will engage with the residents very, very early on, and typically we will do all of the bore field work first. So we'll do that before we get into any properties. So the big impact on the residents then is they'll have basically a building site outside their homes. I've put a picture in here of bore fields because although we're saying it's a very small system, it can actually be spread through quite a large area, and it can do multiple buildings. So in here we've got quite a lot of different bore fields, a lot of different arrays, which will be servicing all of those apartments. The bore fields are typically around 200 metres deep, and there's about 8 metres between each bore field, each borehole. And we usually have 2 boreholes per property. So that gives you an idea of the scale. If we're doing 100 properties in a tower block, we'll typically have 50 boreholes about 8 metres apart. So that gives you some indication of the kind of space that we need. At this point, there's no work being done inside the buildings. All the bore fields will be put in place. all the pipes will be run up to the entrance of the building. So what that means for the residents is there's a lot of work going outside the property, but there's no impact on them internally. We will make sure that there are walkways, that none of the access is restricted. And once it's complete, the residents are then, or we are then able to reinstate that land. So typically it can become community gardens, children's play parks, cycle parks, or indeed car parks if that's what was originally there. The next step would be the internal pipework, and I've just tried to give you some pictures here to show you what it looks like inside the building. At this point, we're still not going into people's apartments. The pipework infrastructure is in the communal areas, so it's typically as you go into the building and coming up to each landing, and then across, in this case, it's going across the ceiling. So it terminates outside the apartments. We're still not going into the apartments at this point, but the residents obviously will have work going on outside their house. We advise the residents exactly what's going to happen. We give them contact details so they know they can contact the resident liaison officer, they can contact the site manager if there's any problems, and we've told them exactly what's going to happen. Where possible, we will box everything in, and we'll also use existing pipe runs, disused refuse chutes to try and reduce the amount of work and reduce the pipes that are on display. But the residents, as I say, are all updated. They know exactly when this work is going to take place and they know exactly what's going to happen. The next stage is actually getting into the properties themselves. And this is where the resident liaison is really, really important, because we need to get access to every property that is being upgraded. And hopefully that's 100% of the properties. And on a recent project where we had 300 units across 3 high-rise blocks, we actually achieved over 99% access rates, and that's purely down to good tenant liaison. The access rates are critical to getting the project completed on time and to budget. If for some reason you go to the house and the resident isn't there, or they won't give you any access, then you'll have a whole team of people that can't do any work that day, and you've then got to reschedule that to try and get that work done at another time. So that has a cost on the project. So we'll typically go into the house the day before the install. We'll update the resident, we'll make sure they've got somewhere to go for the day, and we'll then go back to the property the next day so that we can run through their new system with them. On the agreed day for the install, the resident will typically leave. Now, we'll have had some area set up that they can go to for the day, but they typically go to family or friends just for the day. We will then go in, we will pull out everything that's in the property in terms of the heating and the hot water, and we will actually replace with the new system. We'll install it, we'll test it, and we'll commission it. In this particular property, you can see there's a heat pump. In this case, it's a Kensa heat pump, Kensa shoebox. Other heat pumps are available. We've also got the sun amp, in this case, providing all the heating and hot water. We'll have all the new radiators put in, control systems, as looks very much like a typical gas system, and it will work very much like a typical gas system. There's no need to decant the residents because all of the heating and hot water provision will be provided for them by the end of the day. So they'll come back to their house and everything's in place for them. So just to end on that, resident engagement is absolutely critical for these projects, getting access to as many properties as possible. We will create the engagement strategy with the housing supplier or the RSL. We have very early engagement with residents way before the project starts. We'll arrange coffee mornings, fish and chip nights, whatever it takes to get people together and talking about what's going to happen. They will meet the contractors, they'll meet the resident liaison officer, they'll get to know them very well because they're always on site. We have very good communication with the residents both before, during and after. We'll give them progress updates, let them know what's happening. As I say, we do the pre and the post installation visits, so we'll visit them after the installation, we'll tell them how their system works. We will leave them with a lot of documentation, but we'll make sure that they know how to use it. And we do lots of handover talks, satisfaction surveys, accurate data collection. Another big thing that we do there is the funding, particularly where we've got mixed tenure and we've got a lot of owner occupiers. We look at ways that we can fund all of the work for them as well. So it's really important that we get everybody involved in the projects. Thank you. I'm going to pass over to Graeme from Greystone, who's going to tell you a bit more about ground source heat pumps and the installations.
Hi, good morning, everyone. I don't have a screen show to go through yet. I'm just going to explain the processes of designing and installing ground source. So I'll give you a little bit of background about myself. I'm Graeme Ross, Greystone Energy, and I've been involved in designing and installing ground source since 2012. So we started off with small domestic size systems, moving up over the years, doing systems for hotels. At present, we've got a 200 kilowatt system that we're looking to install. That starts January next year. That one starts. Ground source heat pumps have changed a bit over the years. A lot of the systems now are moving on to inverter-driven compressors from fixed speed compressors, where they were kind of popular back about 10 years ago. As things develop and refrigerant gases are changing with the times as well. We're working on a project at present down Edinburgh, and that system is it's a small commercial one. So we've got a system where it's a 33 kilowatt ground source going in, and that's feeding 2 buildings. So we're using a bit of district heating as well between 2 buildings. The system is doing hot water from a centralised plant room also, and that is going around the 2 buildings and back to the plant room again to be reheated. Drilling for the ground source, again, we tend to work with one driller all the time. We've worked together. We're both members of the Ground Source Heat Pump Association. We've been working together for probably about 8 years now. We're kind of the same as Joan. We kind of do all the prep work. We do all the ground side first before we then start on the plant room side. We have a squad of well, we've got 2 teams at the moment. So we've got 2 installation teams, and we tend to work between air source and ground source. So we do both, but the ground source is becoming more popular, and we are. Oh my dear, sorry folks. Sorry, just a moment. Just. Sorry. We're also looking to start doing multiple dwellings. We also we're looking to work closely with Scottish Power heat networks, and it's very similar to the model that Mark was speaking to earlier on, where all the ground side will be funded, and it will be a rental for connecting to the borehole field. I see us moving into more the commercial side of installation, as well as keeping busy with the domestic side. We looking forward to start the big project next year. We're also designing a system for a hotel at the moment, which that one is a 120 kilowatt system. So it's yeah, no, the marketplace is certainly good for the ground source at present. It is slightly more efficient. We probably get between 500% and 600%, as opposed to the air source, where we're probably 300 to 400% efficient. And a lot of the refrigerants are changing at present. They're going through like a migration. So a lot of the units are moving to sort of low GWP, global warming potential gases. and these can also be higher temperature. So we're at the moment, a lot of the ground source we're doing have the capability to go to 75-degree flow temperature for doing hot water production. So it can pretty much take over from a boiler. But again, you are looking to size emitters and have the system running anywhere from 40 degrees to, we try and get it 40 degrees to 45 degrees on a retrofit. And that allows you to maximise the efficiency of the unit. No, if anyone has any questions, feel free to get in touch with myself, Graeme at Greystone Energy, and thank you for having me on. Thank you.
Hi everyone. Thank you so much to our speakers. That was really insightful and really talking about a lot of different applications of this technology. We are just about to head into our Q&A, but before we do that, we've got another quick poll question. So hopefully you found that informative. So we would love you to let us know whether now you feel a bit more knowledgeable about ground source heat pumps and their applications than you were before the webinar. Obviously, we haven't gone too technically into a lot of detail today, but what we do have is lots of links in our chat box, so you can head over to there to find out more about those individual organisations, the projects that they do, and any more about the kind of technical side. So I'll just let you all answer the poll really quickly before we get into some questions. Just a few more seconds, sorry, to answer. Excellent. Well, that's fantastic. So that's what we want to hear. That's what the HeatSource is here for, is to raise awareness and to kind of share learning, share good practice about technology. So that's really fantastic feedback for our speakers. So thank you to all of those speakers and panelists. If you don't mind popping your cameras back on, and we'll head into the Q&A. Fantastic. Thank you so much, everyone. So one of the kind of first questions, it's directed to Ken, but I think actually there's probably quite a bit of insight to be shared from all of you. But the first question is, as a tenement dweller, I know how hard it is to get agreement to do even basic maintenance in a block. The option to install a ground source heat pump would be a challenge that I'm not sure I could handle. Does regulation seem to be the only way forward as in comparison to that kind of voluntary early adopter challenge? Ken, do you want to speak to that around the kind of regulation and the kind of challenges around that shared kind of occupancy or kind of different occupancy models?
Yes, well, thank you, Malcolm, for that question. Really good question, in fact, as you guys all know. But what we've got to think about is we've heard about ground loops, which is probably new to a lot of people. But as Mark said, really you've got to think of it as the same as the gas network, because if you have a gas boiler, your gas pipe's got to come into the building, and nobody worries about that at all. So we are working with the Scottish Government on their heat networks plan, and there's a big piece of that that's to do with consumer protection. Now, we got quite far on in February this year, and then the Scottish Government had to stop because consumer protection actually comes under UK law. So now that the UK guys have caught up with us, we're on a roll again. But really, what we have to do is it's a two-way thing, is that we need responsibility for utility people like Kensa, and they have signed up to an agreement that's a sort of interim agreement at the moment, so that they will do things fairly. But really, what we've got to do is just get to a point where you don't even think about it, and you just go, yeah, I want a heat pump, and the utility company will provide it for you. And I didn't really go into too much detail on shared ground loops, but it definitely is the way forward for heating in Scotland. It's a very, I mean, if you can take away the cost of that heat network, and you have a utility like Kensa, and there are many others coming, because Scottish Power is mentioned, British Gas is another, and so on and so on. It's a great model for these people to invest in. So once you've got rid of the cost and the risk of the ground loop, then you look at buying the box that goes into your home, and a ground source heat pump is a lot cheaper, because it's just a refrigerator. It's got no fans to blow air through it. It's got no defrost cycle, so that when it blocks up with ice in the winter, and of course it's all efficient. And please do have a look at that long list that I put up there when you get the slides. So sorry, a bit of a long-winded answer to that, but really the answer is it has to become a utility. We are working hard to do that. But in the meantime, I think Joan probably would be able to tell you how, because this is not an answer for a mechanical engineer like me. You know, it's really a sort of social question. So over to Joan. How do you do it, please?
No, it's a great question, because even personally, there's 5 blocks in the development I live in, 89 residents, and it would be perfect for a ground source heat pump. But like you say, Ken, because at the moment these are private residents, so unless there's actually an infrastructure there, like we have with a gas network, where you're only buying the equipment inside your house, it won't happen, because it's just too expensive. So at the moment, I think the people that are going to adopt the ground source heat pumps are going to be the social housing providers, where you've maybe got a block with mixed tenure, but you know, you've maybe got a smaller number of owner occupiers. And then what we do is a funding strategy. We look at how can we get the maximum funding for those. So I think you're right, Ken, you really need the infrastructure to be there first, so that people are only buying the internal equipment.
That's brilliant. Thank you. I knew you'd come up with that. But Mark, you're the guys that do retrofit. So how do you manage to persuade people?
Yes, it's a perennial challenge. We have a lot of retrofit inquiries at the moment, where the housing and the sustainability departments within local authorities and whatnot are dead keen to get the retrofit, you know, the social houses sorted out, and then the roads and planning department says no, you can't put a borehole in the ground. So yeah, there's definitely there's work to be done there, and that work's being done. It's not like it's not being considered. But yeah, with the tenement blocks, we did a project down south which had considerable sum of funding, certainly, and it was called Heat the Streets, and that's available on, you can have a look at the details on that online. And basically it was boreholes in the streets in front of the properties for and we were given statutory undertaking rights so that we could maintain those boreholes and pipework indefinitely, similar to the existing gas infrastructure. So yeah, as Ken and Joan, Graeme will know, we've got the challenge of being able to get those, to have ground source shared ground arrays adopted as an infrastructure in the same way as internet, you know, BT internet and all the others. So it's coming, and that will have a massive impact on the what we would consider to be hard to treat. But we're already speaking with a lot of local authorities, a lot of city councils.
Yeah, well, that's fantastic, Mark. I mean, I heard this story from Kensa, and I wouldn't say I didn't believe you, but I thought, well, I'm going to go down to Stithians in Cornwall and just see what the people think there. So I spoke to the councillors in the Stithians village, and they thought it was fantastic. And they said, well, you know, at the beginning, it was all a little bit, you know, difficult. People weren't too sure. And then after the first ones went in, we were totally oversubscribed. And, you know, everybody that wanted one got one, but there were more as well. But I'm just wondering, you know, Graeme, you unlike us, you're at the coalface. You're actually, you know, speaking to people. I mean, how do you get on with dealing with it?
it just takes a bit of organising. It's I mean, most of the stuff we're doing at the moment is individual dwellings, so it's easy just dealing with the one person, or if it's a commercial building, it's just the one site. But no, I think yeah, right. I think it's we kind of need to have it run just like normal utilities, like the same as the water and the gas and electric is at present, and then people can then decide if they want to connect to that. It's just like getting a gas connection, and there would be a connection from the flow and return from the borehole field to each individual property. But I think that's kind of where we need to get to with GroundSource.
Fantastic. Thank you, everyone, for those insights. And I think, Mark, Kensa have been working on the Heat the Streets project, which I think is designed to be a kind of flagship of, or an exemplar of, like, how do you do this, and what are the impacts. So we'll be happy to share a link to that after that particular project, and the insights and as a case study following the webinar. I'd like to move on a little bit to the kind of the skills side of things. So in general, the transition to green heat technologies is, it's such an undertaking. It's such a scale of change that we need at pace. A lot of times the skills element does come into the conversation. Do we have enough knowledgeable people to deliver air source heat pumps, even doing the kind of design and specification work for large heat networks. With regards to ground source heat pumps, what are some of the kind of skills, challenges, or potentially kind of benefits? Is it easier to install? Is it more simplistic to be qualified to upskill existing engineers? I don't know who would like to take that question. Ken, maybe yourself.
Yeah, I can take that. It's definitely a challenge, but I have to say that really heat pumps, when they first came out, they were like split units and you had to be a refrigeration engineer. But now, whether it's an air source or a ground source for domestic, they tend to be, as Graeme says, they've come on leaps and bounds, and it's just simply a box. So actually, in some ways, they are easier for technicians to install, because you've just got a few pipes. Really, there's no burning flame in your kitchen. It's a positive advance, and honestly, in 30 years' time, people will go back and go, "How did we allow that? Burning flames in kitchen? My goodness me!" So it's not a great thing, but the blockers really are just a lot of the publicity that follows heat pumps that's generated by the press, who see us as an easy target. Heat pumps do work. We wouldn't be here if they didn't, and it's really we just need to help the consumer, and by consumer I mean not only the people that are using the heat pump to heat their homes, but also the people that are going to be installing these. And once we get to that point where they can see that it's a sustainable way forward, then these people are going to jump over. And at the Ground Source Heat Pump Association, we have training courses with various partners lined up that help transition people across to this. And the ground loop is a bit tricky, but as I say, our plan is to really just take that away from the guys that are installing the actual heat pump itself, and work with utilities like Kensa or Scottish Power or British Gas or any of these. Rendesco is another one of our companies, and they offer exactly that to developers, where they'll come and design the whole thing. You don't need a gas main, we'll just pop this in. So it's training is an issue at the moment, but it's not insurmountable, and people will come and join us. Yep, sure. Thank you.
Joan, I think you're wanting to come in on that.
Yeah, I was just going to say that on the communal systems, it's actually an advantage in the fact that you need skilled people for all of the design work to get all the ground source in place, but actually within the properties, once you've designed that, there's a lot of them that will be the same. And it's the technology that's going in there is quite well known. It's radiators, yeah, you've got your indoor heat pump, but it's generally fairly straightforward to any heating engineer, and you've got your hot water cylinder or your sun amp. So actually within the properties, a lot of the work is the same as an electrician or a plumber would do now. I don't know, Graeme, if you would agree with that, or?
Yes, when connecting it, the only thing I think we need to develop through training is more engineers on the refrigeration side. That's all to deal with servicing and fault finding if there's issues inside. But yeah, I think the new training programs are going to go well. I think is there not a new apprenticeship way to go live down south, Ken, for the low carbon apprenticeship?
Yes, we have. Yes, the Greystone Heat Pump Association has developed an apprenticeship, and we've got good funding for that from the UK government. We just need to get it north of the border, but we are speaking to Scottish government and well, everybody up here. And Home Energy Scotland, sorry, Business Energy Scotland, they've got a fantastic facility. They've got a mobile training unit, which we could just bring along to like our village car park here, and just get the local guys to come along and understand what's going on. On the refrigeration side, absolutely, we'll need some specialists on that. But as I did say to one fairly senior government official in the Scottish government, when did you last throw a fridge out because it broke? And the answer was he never had.
Excellent, thank you so much. Mark, I know that Kensa, you do quite a bit of training, and want to touch a little bit on the kind of local supply chain kind of element and how we tackle maybe some more remote or rural kind of communities and local authorities to build up the kind of skills base within the supply chain for that kind of ongoing service and maintenance kind of element. I know that a lot of the time for RSLs and local authorities, there's some concerns about kind of the future proofing. Like say, Ken, they'll rarely completely break down, but inevitably there are often maintenance issues. So I wonder if you can speak to that, Mark.
Yeah, so we have a couple of clients that the project that we mentioned at Ballater at Grampian Housing Association. So they've been installed for a year. So we're going up with our engineers to do their first year's commissioning and servicing and maintenance, and have a look through all the properties, make sure they're all up and running. And during that week-long period where we're going in, the Housing Association will send their own staff to shadow our engineers, and basically once they've done that, they won't need us. So we're more than happy to deliver that training. Likewise, we have another project in Glasgow where the M&E staff with the construction company came down to our training centre in Bradford and spent the day working with our engineers, getting their hands dirty, I suppose, on the heat pumps that we've got up and running in the office. And on a way back up the road now, as Joan and Graeme both mentioned, these are engineers. These are guys that are heating engineers. They know their way around that heating system. All they're learning about is the box, the difference, how to read the information from the box. It goes on an app on their phone, and once the mechanics of it is all very familiar to them. Graeme mentioned the refrigeration, obviously that's a slight different thing, but with regards to from gas. But yeah, we do a lot of on-site support, but we also have the facility in Bradford that we can take people to. In an ideal world, we'd like something up here to make it a little bit easier. We'd like more, we'd like to have more partners within the supply chain that we're able to do to work with us on the full installation development. But at the moment, there isn't the critical mass of, if we suddenly started doing 5,000 heat pumps a year, then clearly the need for a supply chain infrastructure grows exponentially. At the moment, we're not there yet, but everything changes with scale, and that's what that's sort of Kensa, and I'm sure Cenergist, and I'm sure the Ground Source Heat Pump Association. And Graeme, we all want growth. We all want, because it gives us a bit of security and it helps drive down costs.
Excellent. Thank you so much. No, I appreciate that. Absolutely. We might not be there yet, but I think we're getting there, not just with this technology, but a wide range of the zero emissions heating technologies. So yeah, we're on the right path. I think, like you say, it's just about that kind of pace and scale. So I'm just going to go to a couple more of the kind of slightly more technical questions that have come in. So Alistair has asked, what kind of COP, so coefficient of power, should you be looking for in a ground source heat pump? What would be a typical kind of high and low figure? Graeme,
I can answer that if you like. Yep. So the COP is the coefficient of performance, which is what you'll get from any pump, and it tells you how good the pump is. So if, for example, you put 1 kilowatt of electricity into a heat pump and you got 3 kilowatts of heat out of it, that would be a COP of 3. But what happens is that over the seasons, an air source heat pump will struggle in the winter and be better in the summer than ground source. So there is a thing called seasonal coefficient of performance, or SCOP. But we prefer to use SPF, which is seasonal performance factor. So what that means is that really you really want to be looking at getting a good ratio between electricity you buy and the heat that you're getting out. So in my house here, we get a seasonal coefficient of performance of 6. Now, most people go, what? Is that right? Where did you go wrong? And the reason we did it is because we have low temperature emitters. The floor is heated with water that's only 29 degrees. We have solar panels on the roof, and as you can see today, even though I'm in Aberdeenshire and the snow is on the ground, we have sunshine streaming in. So during the summertime, those solar panels heat my water, and it means that the heat pump doesn't come on. And as I mentioned right back at the very beginning, the more temperature you have to get up to, then the less efficient the heat pump is. So if in the summertime, all your heat's coming from the solar panels and your heat pump's just having a little snooze, then that's how you get a coefficient of performance of 6 like I do. So normally we'd be looking for something though of a coefficient of performance of around about 3 to 4 is deemed to be good. But everybody could have 6 if they want to. Floor heating, solar panels, go for it.
Great, thank you so much. Yeah, I think maybe comes to another question about the kind of the integration and how well does and how easy does ground source heat pump technologies integrate with existing or other technologies, whether that's renewable generation or storage or thermal storage, for example. Joan, I think you guys kind of like say your turnkey solution, looking at energy efficiency as well as kind of multiple different technologies. Do you find that the ground source heat pumps are pretty integratable?
Yeah, I mean, so typically speaking, once you've got your ground source heat pump in place and you've got all the pipework into the building, so you've got the water going into the building at a sort of low temperature, then it's up to you what you put inside that building. So we can work with lots of different heat pumps within the building. We have worked with a lot of the Kensas, but we also work with the SunAmp because it works really well with the Kensa. As Ken said, he's using solar, so that's actually contributing to his seasonal COP. So that isn't all from the ground source heat pump. So yeah, I don't think there's any limits on what you can integrate. Mark, were you going to say something?
Can I just add something there as well? There's loads of options to integrate. So as Ken says, he's got PV on the roof. The PV generates electricity. That electricity can help run the heat his water, etc. But we've also got the option, and I think it's becoming more popular, for battery storage. So if we put battery storage into a garage or whatever, and we can draw down energy and store it with the low tariffs that a lot of for example, Octopus Energy, I think, are doing half-hour tariffs now. Some really good low cost electricity. And if we store that in a battery, and then we use that stored battery energy to run the heat pump at the peak electricity prices, suddenly you get a far greater your COP, then your coefficient of performance increases, because you're actually using much cheaper electricity. So all of there's lots of ways of developing the functionality to maximize the reduction in cost that decarbonising the homes will undoubtedly bring about. But the battery storage is exactly the same as the heat pump technology. We need scale. You know, we need assurances. You know, security in terms of getting that into the housing stock. So, but there's lots of ways to, you know, we charge the battery with PV. We don't pay anything for the electricity. We then run the heat pump to heat the water free of charge. It can be done. Is it expensive at the moment? Yes, it's possibly a challenge financially, but there's ways and means of, you know, there's funding and there's grants available. And as Joan said, add a sun amp thermal store into the mix, and you know, all of a sudden you've got a pretty efficient system for heating your home and hot water.
Great, thank you. And there's a slightly kind of follow-up question for you, Mark, there. So from Malcolm said, the schemes that you mentioned, like the Fountain Bridge one, looks like it needed a big investment to install. You know, you have mentioned the cost there. Typically, kind of what's involved in terms of that kind of outlay and the kind of return on investment there? Maybe it's you know, payback period or things like that you're coming across in your bigger projects. Yeah,
so the project cost per property was no more or less expensive than most other new builds. So it was a bit of a challenge, I guess, logistically on site, because they're a really tight site. We tried to go to the site and there's a little street between the properties next to the canal and the actual site, and I struggled to get my car down it. And I was watching guys with flatbed trailers and drill rigs going up there, going, you know, kind of behind my fingers, going how they're going to wreck stuff. But they did a brilliant job. So logistically, it was, you know, physically on site was a challenge, but the financial cost was no different to any of some of the other new build sites that we've been on where we've had loads of space. There was no funding used for that site. The developers paid for it, and obviously that'll probably be reflected in the cost of the houses when they sell them. So that will go onto somebody's mortgage, you know, when they purchase the house. But yeah, it was challenging because everybody said it couldn't be done because of the site, and why would you be drilling right next to the water and whatnot. And we did. I noticed one of the questions on the chat, I think there was a consideration for water source, but it was just considered to be neater and more efficient to put in the boreholes on the site. I think there's about 8 boreholes. There was only about 8 boreholes on site, so it wasn't that onerous a drilling project. So yeah, but it was surprising at just how little, you know, the impact there was on the cost compared to some other new build sites. Retrofits generally more expensive, generally more expensive than new build, but you know, we're doing our best to keep those costs down.
Excellent, thank you so much. A couple of kind of temperature related questions there. So it was mentioned, I think, Graeme, in your presentation, your discussion, that the systems kind of run at 40 to 45 degrees. The question is, how does one get a decent water temperature for a shower, like, for example, which may link into another question around, is it a common approach to separate space heating and hot water provision? Is that a typical kind of approach?
Yeah, so hot water and the heating are separated within the heat pump. So it's the same as a normal heating system. It heats the hot water, puts heat into the radiators. So the flow temperature on the heat pump can can vary depending on what temperature you want the hot water at. So with a lot of refrigerants now, you can get a maximum temperature the same as a boiler. You can get up to 70, 75 degrees from natural refrigerant. So you can store the hot water between 40, 50 degrees, 60 degrees, and then when it flicks over to heating, it'll then run on weather compensation normally. So that means it'll vary between the 25 degrees and 45 degrees, depending on how cold the outdoor temperature is.
Joan, I think you wanted to come in on that slightly.
It was just, I'm not sure if I misunderstood the question, but I guess the heating and the hot water are both being supplied via the ground source heat pump and the Kensa shoebox. So they are integrated. You can get a combined heat pump cylinder, so it's in one unit. So that's another option. So just to be really clear that we're not heating the water separately from the ground source heat pump loop.
Yeah. I think as well, kind of what you've mentioned there about kind of lower flow temperatures within the home heating system is essentially what you want. And I think even for those of you in the audience, you know, we are coming into heating season, there is lots of advice and guidance out there about how to turn down your existing, whether you're on gas, to turn down those flow temperatures that will kind of increase the efficiency of your existing heating system, even on gas. So, you know, lower flow temperatures are kind of more desirable, obviously, for non-gas systems, but you can still feel a benefit on the efficiencies for gas central heating systems. So,
one last thing on that. The heat pump, the Kensa heat pump, diverts the heat to prioritise hot water. So it can be set at 60 degrees for the hot water. The minute the temperature in the hot water cylinder reaches that, it diverts back to the central heating system, which I think is what Graeme kind of alluded to. And then it runs the heating until the temperature comes down. So, but you can run the two at different temperatures. Sorry, Ken.
Yeah, sorry, no, just going back to Ellie's question there, and she's asked, you know, SunAmp was mentioned. So Joan showed a Kensa shoebox and the SunAmp unit. Now SunAmp is another great company built in Scotland, in Trinent, and these are clever little devices that have a phase change material in it, but actually what it is it's like a big box of wax that when you melt it, it takes extra energy to melt it. And that's called the latent heat. And so when it then solidifies, you get that energy back. So it's more than just like a hot water tank where you're just storing the sensible heat. It actually gives you the latent heat as well. Now, it was mentioned by Joan that that's available with the Kensa shoebox. Could possibly explain just how you work the two together, please?
Yeah, so I think Mark and I, between us, basically it functions as a hot water cylinder. I mean, just full disclosure, I worked for SunAmp for a long time, so yes, I'm delighted to see them being used so much. But basically it just works like a normal hot water cylinder insofar as the heat pump itself actually charges the SunAmp, which is kind of the same as heating the water. What it's actually doing is heating the phase change material, so the cold water will flow through the pipes in the phase change material and come out hot. So we're just using it exactly the same way as we would with the cylinder. I don't think there's any major difference there. It's just much smaller, much more efficient. Mark, I don't know if you...
I was just going to mention on that retrofit element where sometimes space can be a real premium, and it can be quite difficult to find a space for a large cylinder. So you've got that large thermal store, and it's
one of the advantages of being able to split it, because you might, you know, you can sort of be a bit more flexible about where you site the equipment.
And as Ken says, the heat loss. Sorry, go on.
Oh, sorry. I was just going to say also the benefits with the SunAmp. You, like a normal unvented cylinder, you've got to have your safety discharge, and you'll probably have to do with some systems, depending on the temperature you store at, you need to do a look at Legionella, whereas you don't have that with the SunAmp.
Great, thanks everyone. One more temperature question. So in terms of the opportunity or the potential to integrate ground source heat pumps and shared loops into a wider city scale heat network, what would you think is the optimal, or what is the optimal heat flow temperature and return temperatures that you'd be looking for in order to allow that interoperability, or are they going to be quite separate? You know, there are specific areas that will be those shared loop kind of communal heating is maybe a more appropriate kind of term versus larger heat networks.
So from our perspective, we're taking between 8 and 12 degrees out the ground. So a district heating network, for example, will have pipe work from the central heating plant to properties and buildings within that network zone. And as it gets towards the edge of that zone, the valuable heat, the heat that can be used to heat the properties, reduces. Shared ground loops can then use some of that unsuitable low-grade heat to heat the pipe work and extend the distance that heat network can then supply heat. So we borrow some of the low-grade heat from the system, from the district heating network. That has two positives. One, makes the heat pump shared ground array a little bit more efficient, and it also makes the district heating network more efficient because the return temperatures to the big central plant are reduced. So it works more efficiently. We are using more of the, as Ken mentioned with his sun amp, you're using more of the latent heat. So it's great for extending the heat network. What those temperatures are, anything, we're taking between 8 and 12. If the heat of the ground is 20, then clearly that's not going to be enough to heat the property, but it will be enough to add some temperature to the shared ground loop, which can then make the heat pump more efficient. So there's lots of ways. Data centers, for example, I mean, most data centers are not in urban areas, however, they do generate a sizable amount of heat. And again, if we can get a way to put that heat back in the ground, and we can draw that heat from the ground when we need it, that's a good way of using. And that temperature in the ground, all we're trying to do is raise the temperature in the ground next to the pipework.
Excellent.
Yeah, that's perfect, really, because if you just go back to my analogy with the little hill with the pump, it's all to do with how high you're going to pump it. So if your reservoir is not at the bottom of the hill, as Mark's saying, but halfway up, then it's going to take less energy to heat it to where you need it. So it's just kind of basic physics. Thanks, Mark.
Fantastic. I think we've got time for just one more quick question. We've got about 3 minutes left, but I think this should be a relatively easy one to go to look at. So Jenny has asked, are there grants for getting a street kind of preliminary design and costing in order to be able to kind of try and sell the idea to neighbours to kind of come together for that? I don't know if there's any advice from the panelists on that.
So it kind of is the answer. I think the best thing to do would be to call the Scottish Government's Heat Network Unit. So there are grants for doing the systems, but they will also supply a grant for actually doing all the feasibility study. If it's a private street, it is really difficult. So, the grants that are available for actually doing the works won't cover the whole cost. And, like I say, in my street, it's really difficult. Most people have got a gas boiler. Some of them will be about 15 years old, so although they need replaced, I know it's much cheaper to actually just buy another gas boiler. But the Heat Network Unit are actually incredibly helpful, and they will tell you, I think they'll offer up to £50,000 to actually do the feasibility type studies. So I don't know if that helps.
We have popped a link to the Heat Network Support Unit in Scotland into the chat, so you can find some information there. It may also be worth looking at some like Snug Energy or Novaville, who are kind of developing apps in order to engage people within, disparate people within communities on kind of shared repairs or kind of shared decarbonisation methods. So again, we'll pop some links in some of the post-event communications around that as well.
Could I just say something, because there's a great question in here about gas, and I think it was Fraser that asked it about, can a ground source heat pump compete with an individual gas boiler? And it's a brilliant question. It's one that I love, because in the past, having taken out my gas boiler and put in a heat pump, I'd still have told people stick to the gas because it's cheap. But I'm now seeing people where the cost of gas has risen to the point that the COP of the heat pump means it is actually cheaper to do a communal heat pump system. So it's a really good question. Happy to share some numbers if he wants to get in touch, but I think we are at the point now where the ground source heat pump can compete very well with the gas.
Could I just say there's quite a few other questions there that are unanswered. So if Emma, if you could share them with me, I'll speak to the team and we'll get answers and we'll put them back to everybody really. Yeah. Thank you.
Great. So we are at the end of our time, sorry, and we're slightly over. Just thanks again to all of our panelists and speakers for joining us today. Thank you to our audience. We hope you found that informative and insightful. We will share a link to the recording, the slides, and also a list of the questions posted and the answers from our panelists, like say, even the ones that we didn't get around to. But thanks again to the audience for being so involved and asking lots of great questions. Enjoy the rest of your day, everyone, and we'll see you at the next HeatSource event. Thanks, everyone.
Thank you. Bye.
Bye. Cheers.